Yes, students. Good afternoon, everybody. We shall start the class now. Um, I request anyone to volunteer yourself to sum up what are all the contents we have discussed in last class. Yes, Giriraj. Giriraj, unmute yourself. Yes. So what are all the contents we have discussed in last class? Can you please sum up? Giriraj, you are not audible.
That small network issue, ma'am. It's like a bad
Okay.
network connectivity.
சரி பரவாயில்ல. என்னென்ன கான்செப்ட் படிச்சோன்னு மட்டும் சொல்லுங்க. லாஸ்ட் கிளாஸ் என்னென்ன கவர் பண்ணோம்?
Ma'am, like requirement specifications for phases of object orientation analysis design, ma'am.
Yes, good. And then we have started about the introduction of classes and objects. Okay, unmute yourself. I'm sorry, mute yourself. So, good afternoon, students. Now, actually, last class we have discussed about various parameters of object-oriented concepts. Okay, and then we have discussed about few slides about the phases which are all present in OOAD for the development of the software. And this class will be covering about object-oriented concepts. Okay, so while dealing with object-oriented concepts, as the picture clearly says, there are 6 major concepts or principles of object-oriented analysis and design. So let me start with object. Object is the first principle. Okay, object is the first most principle, followed by class, and then 4 major other principles are abstraction, polymorphism, inheritance, and then encapsulation. So these are the 6 major principles or concepts of object-oriented analysis and design. Now we shall start with what is object. As we have already started this concept in the previous class itself, an object is said to be an instance of a class. Okay, so a class. So what is a class again? Last class, one of your friend has addressed that class is a template which is going to hold a set of objects that are much more similar. Okay, so class is a template and an object is said to be an instance of that particular class. Okay, so this is a definition of what is an object. So this type can be represented as any class or interface that contributes members defined defined in the object class hierarchy. So what is the meaning of this is that here we can have a set of hierarchy of objects where the particular their properties and attributes will be contributed to complete members which is present inside the object. Okay, so the meaning of this is that all object will have same characteristics. Okay, so characteristics means it will be having a set of attributes and a set of behaviors which is called as functions. Okay, so here are some of the types of objects. So literally speaking, we have 3 major types of objects. First one is called as physical entities, and second is conceptual entity, and third one is called as software entity. So as I've already said you, any particular entity that is physically existing in this world is called as an object. So any physical concept which is present over here, for example, let it be a PC, a laptop, a charger, anything which is physically existing is called as a physical entity. Next comes something called as conceptual entity. So what is conceptual entity means? Even a set of chemical components which combine together to form a chemical substance, or any concept can also be an object. Remember this, a concept which is present for the development of a software, which is used for the development of a software, can also be an object. And third one, even software can also be an object. Okay, so whenever you're defining a problem statement, to develop a software for employee payroll system. So there, even employee is an object which is a physical entity, and database is an object which may be a conceptual entity, and even the particular set of code which is used to compute the pay scale is again a object. So even physical, conceptual and software can be an entity which comes under the division of objects. Next is the definition of class. As we have already said you, class is a blueprint or it may be a template for an object. And class is mainly used to group a set of objects that is having common attributes and common methods. And keep in mind, there is no storage is assigned when the class is defined. Only when you create objects, then the storage will be defined based on the attributes and methods. Imagine you have 2 attributes and 4 methods. Your storage, that is memory place, will be created for those attributes and the methods for each and every objects. Okay, so placing data and functions together into a single entity, which is called as a class, is the main idea, that is central idea of object-oriented programming. So here is a traditional example which we have discussed in the last class itself. For example, there is a class called as vehicle. So vehicle may have objects such as truck, car and bus. So whether truck, car and bus are all objects, not always. Keep this in mind. Okay. For example, if a truck has that is a physical entity, physically if there is a truck available, that alone is called as an object. A group of trucks can also be a class. Remember this. Okay, so keep this picture in mind. So here I am just again elaborating the class called as car. Okay, so car is again a class. Why? Because for example, a particular car which is red color and which is of made Ford is an object. So remember, any particular entity which is physically existing, which has unique properties, is called as an object. A group of such cars like red car, blue car or green car, everything together can form a particular car class. So always car, truck and bus cannot be an object. A particular car, a particular truck and a particular bus is an object. So you people has to understand the difference among classes and objects always. The next concept is the predominant definition of what is abstraction. So this is a basic principle of what is a basic principle of object-oriented analysis and design. So remember, I've already said you abstraction means it is defined as a process of identifying only the required characteristics. Okay, so an object can have n number of characteristics, but which are all required for a particular project. Okay, you're going to define those alone and simply ignore the irrelevant details. So this property is called as abstraction. For example, you can see imagine I'm going to develop a student mark management system. So in this particular mark management system, there are several properties. So here student is a object. Of course, it's a class, one particular student is an object. So whenever you go for properties and functions, roll number, name, class, semester, courses, mark, these are all essential properties for student mark management system. But there are some other properties like height, weight, color, age, etc. These properties can also belong to student. But these properties are not relevant to student mark management system. Remember, for this application, these are all the required properties, but these properties are not required for this particular application. So such property of considering the required properties and ignoring the irrelevant properties are called as abstraction. Similarly, if you take functions, get details, process, display details are essential for student mark processing system. Similarly, some other functions is also available for students like play, game, drive, etc. But these functions are irrelevant for this application. That's why, concentrating only on essential attributes and leaving away unnecessary properties is called as abstraction. Another example, say here, whenever you are opening an IEEE paper or any particular conference paper, the first part of the paper will be always, we define something called as abstract. Hope you people have seen it. So what is it abstract? It is going to say the important parameters, which are all essential concepts of that particular paper, is called as abstract. Similarly, relevant to the keyword, we have abstraction, which is going to concentrate on essential characteristics only. Okay, hope you have understood this. So take this picture into consideration. So here there is a physical object called as car. Okay, so for example, a car user, he is an end user. He will think of number of seats available in the car and what is the mileage of the car, etc. That's all. Okay, that is his concentration. So that is one level of abstraction. But if you take an automobile engineer, okay, the engineer will concentrate on the speed, the engine characteristics and the fuel capacity, all those things. This is the concentration of an automobile engineer. So each and every person will view the particular object in their perspective. So such a view or such particular characteristics of considering the essential for the particular person is called as abstraction. Okay, the next important parameter is called as encapsulation. So what the name says here, you can see the picture also here. You can see there is a capsule which is going to cover something. So such property is called as encapsulation. It is also called as data hiding. As the name says, it is a mechanism that is going to bind, that is, it is going to combine the code and data. Okay, so if you change the code, the corresponding data will get updated. If you change the data, you can do only by means of this particular code. So that particular combination, that is the binding, is done by something called as encapsulation. The advantage of this is that it is going to prevent the data from being accessed by some other code which is present outside the focus. Okay, so here your variables, your methods, your attributes, everything is covered inside this capsule. So this cover is done by something called as class. So using class, I'm able to cover the variables and methods in order to protect them. Okay, so this we can discuss by using an example. So this is a traditional example we have. I'm using Java code for this. Okay, so there is a class called as sample. And I'm having two attributes inside it. One is called as A, other one is called as B. And there is one function called as change, which is taking one attribute inside it. Okay, so inside the code, I'm just changing the value of A such that A will be equal to A plus B plus I, the value whichever I'm passing. And this is called a system.out.println, where I'm printing the value of A. Now, here comes the main part of the code. So what happens here is that I'm going to create two objects called as S1 and S2. So once this is done, a separate memory space for S1 will be created and a separate memory space for S2 will be created. Remember this. Okay, so inside S1, there are variables called as A, B, and then a function called as change. Similarly, for S2 also, there are values called as A, B, and a function called as change. Okay, so if I assign S1 dot A, obviously this A value will be assigned as 10. Similarly, S1 dot B, this B value will be assigned as 20. Okay, and similarly again, S2 dot A, so here the values will be populated as 30 and then 40. So what is the concept here is that if I change A, okay, here if I change A, the value of S2's A will be changed. Remember, S1's A will not be touched at all. Okay, so only the function change, which is called by S1, alone have the rights to change the value of S1's A. Okay, so see here what happens. I'm just calling the function called as S1.change and I'm passing the value 10 over here. So obviously I value will be passed as 10 here and the value of A, which A? S1's A, okay, will be changed as 10 plus 20 plus 10. Okay, so the value of S1's A is changed accordingly. Keep this in mind. S2's A value will be never changed by S1's function. Similarly, S1's A will be never changed by S2's function. So this property is called as encapsulation. Only the corresponding objects, attributes and functions may change the attributes value. Other objects function will never touch some other objects attributes. Okay, hope you have understood what I'm trying to say. So this aspect is called as encapsulation. The next property is called as inheritance. As you all know, this is a mechanism in or Java or object-oriented programming by which one class can allow to inherit the features by some other class. Okay, so here we have two classes. One set of classes is called as generic class and other set of classes is called as specific class. So generic means it is also called as super or base class. Specific means it is called a sub or derived class. Okay, so generic class is going to maintain a set of attributes which is accessed by that particular class alone. But the specific class, which is inheriting the generic class. So for example, imagine there is a class called as G, which is generic class, and there is a class called as S, which is specific class. So the class which is specific can access the attributes which is present inside this class, and also it can access the attribute which is present in the generic class. Okay, so the main advantage of this inheritance is that imagine you have, you have properties belonging to your parents, and you are the only child for your parent. Obviously, the house, the car property or land property, everything which is accessed, which is purchased by your parents, is simply accessed by you people. You can simply inherit those properties. Okay, and the reverse case, if example you are owning a mobile phone, okay, the particular as per rights, it is not accessed by your parents. Okay, so this is a real-time example of what is inheritance. Similarly, imagine you also have a sibling like this. Okay, thing is that your brother or sister can also access the properties belonging to your parent. But your properties will not be accessed by your sibling, and your sibling's property cannot be accessed by you. So this property is called as inheritance. So can anyone say what is the advantage of inheritance? Advantage of inheritance. Yes, Priya ji.
Ma'am,
Priya ji, yes. What is the advantage of inheritance, ma? Priya, you have muted. நெட்லலாம் செக் பண்ணி சொல்லக்கூடாது. Just know, just say whatever you know. Never mind it's right or no.
ma'am,
Yes,
tower problem.
சொல்லு.
I'm not hearing, ma'am.
சரி. ஓ, கிளாஸே கேட்கலையா? கிளாஸ் எதுவுமே உங்களுக்கு வாய்ஸ் ஆடிபிளா இல்லையா?
மேம் கொஞ்சம் ஸ்டக் ஆகுது மேம்.
சரி, ஓகே. இன்ஹெரிட்டன்ஸோட அட்வான்டேஜ் என்ன? இந்த மாதிரி நெட்வொர்க் இல்லனால சொல்லக்கூடாதுமா. இது வந்து இட்ஸ் லைக் a physical class itself. Okay, Rubika. Rubika, yes.
மேம் ரீயூசபிலிட்டி மேம். அந்த கோட் வந்து நம்ம திரும்ப அங்க போடணும்னு அவசியம் இல்ல மேம்.
Yes, very good, Rubika. So the main advantage of inheritance is reusability. As I've already said you, if there is a property, okay, if your mother or father holds a fantastic, house, you can reuse it. You never need to build again. That is called as reusability. If there is a code which is present in generic class, you can simply, access it. You need not write from scratch again. Okay, this saves memory, this saves, performance, everything. That is the main advantage of what is inheritance. Okay, so there are various types of inheritance. First one is called as single inheritance. So, or single level. Single level in the sense you have only one parent, only one child. So class A is a parent and class B is a child. So class A's property is simply accessed by class B. That's all. Next is called as multi-level. Multi-level means you have a parent class, a grandparent class. A is said to be grandparent class, and class B is a parent, and class C is child. So the idea here is that class A's property can be accessed by class B. Imagine your grandparent is having a land. Okay, it is accessed by your parents, and also from them you can also access. Similarly, imagine your parent has bought a house. Okay, this is not accessed by your grandparent, remember, but you can access it. So class class B's properties can be accessed by class C, but it cannot be accessed by class C. And finally, the subclass, okay, that is the last level class, class C. So he can access all the properties of class A, all the properties of class B. but he cannot, I mean, all the properties are his own properties. Okay, but the reverse is not possible. Class B or A cannot access class C's properties and functions. Okay, this is called as multi-level. You have various levels like which it can go on, class D, E, F, etc. And the next last one is called as hierarchical inheritance. So in hierarchical, I have one parent and many children of the same level. Imagine, I mean, remember, they should be in the same level. That is called as what? Hierarchical inheritance. So again here, you have a parent, yourself and your sibling. Both can access class A's property, but the reverse is not possible. Okay. So apart from this, you also have multiple inheritance. Remember, single, multi-level, hierarchical or predominant type of inheritance. But apart from it, you also have something called as multiple. Okay, have anyone heard about this multiple inheritance? There is a problem in multiple inheritance. Okay, so tomorrow, you people just browse the internet and get idea of what is multiple inheritance and what is the drawback in multiple inheritance. Remember, multiple is not supported by many many object-oriented programs, especially Java doesn't support multiple inheritance because there is a problem inside it. Tomorrow I will be asking any of you people to address what is multiple inheritance. Okay. So here is a real-time example of what is inherited. What is the three types of inheritance? Okay. So first one is single level. In single level, you have an employee and a programmer. So employee is like a manager and programmer. He or she needs to get instructions from employee and he can program it. Next is called as multi-level. In multi-level, there is a super class called as employee and developer, and this is more specialized class which is called as Android developer. So employee can be developer, HR, anything. Okay, developer can be of Android or OS, Windows developer, anything. So, but here the specialization goes like this. This is more generic class and this is more specific class. And finally, hierarchical inheritance, you can see employee can be a HR, a manager, and accountant. These three people are of same level. Okay, but here the level is different. Developer is a super class, but Android developer is a subclass. But here three different classes are of same level. They are equally important. Okay. The last property is called as polymorphism. As the name says, polymorphism means many forms. So poly means many, morph means many forms. Okay. So the idea here is that I can use the same function name, but I can make the function to perform multiple actions. Okay, so you can see this example. This is the predominant example which you people are using in Java programming. So what is the function here? I'm having system.out.println. Obviously, println is a function which is present inside a class called as out, which is again present inside the superclass called as system. Okay, so println function so in the first line, println function is accessing a string concept. I'm passing a string variable over here. In the second line, just observe this. I'm having an integer variable called as I, which is assigned as 10. And here I'm passing integer as a parameter. Okay. In the third particular scenario, again the same function called as println, where the first part I'm giving a string, and then in the second part I'm giving an integer. Okay, so this is a combination. Even I can pass float variable. Okay, any variable I can pass inside system.out.println. So I'm having the same function name, but here in the first function, it prints a string. In the second function, it prints a I, that is an integer variable. And in third function, it prints a combination of these two. So the functionality of each and every function is different, but the name of the function is same. So this aspect is called as polymorphism. So what might be the advantage of polymorphism? I'm having code reusability, and also it is going to reduce the complexity. So what is the complexity? Means imagine I'm having three different functions name over here. One is called as print string. Other one is called as print integer. Other one is called as print combination. So it is very tough for us to remember the name of the functions. I'm just using println as a function name. So for remembrance and for reducing the complexity, I am using polymorphism. Okay, so real-time examples are present over here. Okay, so imagine three objects are there: car, Ford, and Honda. So in all the automated vehicles, I will be using a function. I can use a function called as move. That's all. So what happens over here? Move will just move all the name of the function is same, which is move. It is going to for the first instance, it is moving an Alto car, and the second function it is moving a Ford car, and in the third instance it is moving a Honda car. So this is a real-time example. Another example, you can see the bottom of the picture. I'm having a microwave oven. I can bake a cake over here, or I can reheat some food over here. So the functionality is baking here, heating here. So anyhow, I'm using the same function, that is same parameter for multiple uses. This is called as polymorphism. Okay. So hope you people have understood the major properties of object orientation. So what's the first one? We have discussed about objects, classes, and then we have discussed about four major principles: abstraction, encapsulation, polymorphism, and then inheritance. Okay, so these are some of the merits of object orientation. It is mainly used to improve the software development productivity and maintainability. It has faster development, low cost. Similarly, it is going to give you a high quality software. So some other merits are simplicity, modularity. So what is the meaning of modularity? Means I can divide my software into modules, and I can work with one module without the dependency of some other module. Modifiability. I'm releasing one version of a software. Again, I'm trying to have some additions or changes in the previous version. Yes, I can do. Without too much of cost, without too much of time spending, I can easily modify. That is called as modifiability. Extensibility. So without modifying, if I wish to just add some more parameters in the existing software, yes, I can do it. That is called as extensibility. Easier maintainability. And finally, reusability. These are some of the merits of object orientation. And the last slide is demerits of object orientation. So even we have such many merits, okay, there are some very few, okay, lightweight demerits also there. One is called as complex design. Even, okay, the thing is that object orientation may give you a fruitful software, but the work which we have to, do prior to the implementation, which we call it as design, that leads to a complex work. And it takes time to get you people to understand about object oriented concepts. Then only you can start programming. Okay, right from scratch, if you wish to program, you cannot do on the day itself. You have to take time to learn about this concept, and then only you have to familiarize yourself, and then only you can work with object oriented programming. And then this obviously leads to, in some few occurrences, it leads to larger program size, and many instructions we are in need to keep in mind to execute such programs. And in some cases, it may be slow in execution speed due to this larger size. So these two drawbacks occurs very frequent, very rarely. Okay, so some of the demerits, it may be also asked in your placement point of view. Just remember this, demerits of object orientation. Okay.